Hey, what's up, guys? Hope everybody's doing well and having a great day. I know most of you have heard about the Carrington event of 1859. It was the largest on record solar event ever recorded here on the Earth. Once again, that occurred back in 1859. Article over here at popularscience.com, dated October 24th of 2025. Here's what scientists are doing today in 2025, just in case another Carrington event were to occur. And guys, we don't know what the sun's full capability is. A Carrington event can happen tomorrow. There's still a lot to learn about the sun and the earth as well. But back to the article over here at Popular Science. It goes on to say governmental disaster preparedness isn't limited to crises that originate here on Earth. In fact, experts know that some of the most disruptive and unpredictable occurrences begin on the surface of the sun. For weeks now, emergency planners at the European Space Agency, the ESA, in Darmstadt, Germany, have been conducting test runs to improve response capabilities for cataclysmic solar storm. And while today's digitally interconnected world means that such an event would inevitably disrupt global systems, researchers are working to ensure humanity has the biggest lead time possible to avoid a worst-case scenario. And that's what they're working on, trying to get satellites up there to monitor the sun a little bit closer and give us a big heads up, because the Carrington event back in 1859, once the solar flare launched off the sun, it was here at the Earth in less than 16 hours. Solar storms are semi-regular events in which the sun belches gargantuan plumes of energized dust and gas towards the planet at speeds as fast as 2 million miles per hour and even faster. These waves and shock waves can disrupt the Earth's magnetosphere and generate the majestic hues seen during aurora events. The consequences go far beyond a dazzling show in the night sky. Geomagnetic storms can easily scramble satellite constellations, power grids, communication arrays, and essentially any other electronic or geospatial-related infrastructure, GPS, everything that we depend on today, smartphones. I know we don't necessarily depend on satellite TV, but that would be interfered with, and of course GPS, and the list goes on and on and on. Another Carrington event, although a severe solar storm made headlines last year, a 166-year-old event, still remains the most powerful bombardment on record. In August of 1859, what's known as the Carrington event struck the Earth with enough cosmic force to produce northern lights as far south as Central America, while also frying early telegraph systems. The Carrington event was bad enough almost 2 centuries ago, but such a powerful solar storm today could hobble a society reliant on electronics, basically throwing us back to the Stone Age. One of the biggest issues would be how tens of thousands of satellites above our heads might respond. Currently, the ESA is readying the November 4th launch of Sentinel-1D, the first of 2 orbital payloads intended to provide a constant stream of surface imagery of the Earth. And according to Sentinel-1D's Deputy Director of Operations, Thomas Ormston, there's only so much experts can do to protect the kind of multi-million-dollar projects that they're currently working on. Should such an event occur, there are no good solutions. The goal would be to keep the satellite safe and limit the damage as much as possible. And during the training scenarios, planners did not hold back through their run-through. According to the ESA, the workshop centered on a simulated X-45 class solar flare. That would be a Carrington-level event, featuring such an X-ray and ultraviolet radiation that would disrupt radar, communications, and of course GPS data approximately 8 minutes after launching from the sun. That is quick. 3 waves of energy. Unfortunately, such an emergency wouldn't include just a single burst of cosmic energy. About 10 to 20 minutes later, a second shockwave of high-energy particles, including protons and electrons and alpha particles, would strike the Earth at nearly the speed of light, frying Sentinel-1D's onboard electronics and causing possibly permanent damage. And in all reality, it's the third strike that would be most costly. This is the moment when the coronal mass ejection, the CME, arrives at the Earth, moving at 1,242 miles per second, maybe faster, triggering a gigantic geomagnetic storm similar to the Carrington event or last year's outburst. Observers on the ground would be treated to a colorful aurora show well down to the equator, but that would likely be very little compensation for the electrical grids collapsing, power lines surging, and satellites falling out of orbit. Should such a storm occur, satellite drag would increase by a staggering 400%, and that's one one of the primary issues with CMEs, even random CMEs today. The density of the CME definitely creates a different space weather environment around the Earth, and satellites are like plowing through snow whenever these big waves of energy come towards the Earth, and it does slow them down and disrupt their functions. And in some cases, it could throw the satellites completely off their orbit. Planning for the future, it's far from hopeless. However, the Sentinel-1D training offered the first chance to run through the dire event in collaboration with the ESA Space Weather Office. In the meantime, the ESA is continuing with its distributed space weather sensor, D3S, that provides up-to-date data sources. Meanwhile, the agency is doing all that they can to prepare for another possible Carrington event. And it's not necessarily a question of if it's going to happen, it's just a question of when it's going to happen. The sun is still a big mystery. It's constantly in a state of flux. It's constantly changing, and we really don't have a complete comprehensive understanding of the sun's full capability. But in the meantime, we can always learn and be prepared for another possible Carrington event. After all, we are in solar maximum. And guys, just for fun, I have a rogue and random picture slideshow to share with you guys. First photo is out of Knoxville, Iowa, sent in by Mike S. of a highly photogenic roll cloud / shelf cloud above Iowa. Here's another one out of Indiana, sent in by Freak Show. Highly photogenic skies, Florida, Lawrence. This looked like a big triangle up in the sky. Even though it was just a cloud, it didn't look like an ordinary cloud. It almost looked like an intelligently designed structure sitting in the sky above Florida. You guys have all seen what they call the cat's eye. It's a planetary nebula that's been picked up by some high-powered telescopes. Well, look what was picked up on the ground down here out of Allentown, Pennsylvania by Laura. A cloudy night involving the full moon and some very colorful, unique clouds above Pennsylvania. It recreated a cat's eye nebula in the sky above Pennsylvania. Are you serious right now? You can't make this stuff up. Thanks for watching. Have a super day and be safe out there.